need to access whether data from one server and templates from another, without writing separate connection logic for each. We'll configure a single FastMCP client that automatically routes requests to the correct server based on URI schemes like weather, // and resource, //, showing how the same read resource call works across distributed services when you've properly set up your mcpServers configuration.
Async with client, #multi-server client. #access resources from different servers. Weather icons equals await client, read resource. Weather, // weather /icons /sunny. Templates equals await client, read resource. Resource, // assistant /template /list. Print F weather icon 0 blob. Print F templates, template 0 text.
This demonstrates the configured multi-server resource federation pattern, where a client accesses distributed resources through scheme-based URIs that map to pre-configured server endpoints. The core concept is URI to server resolution. Each scheme like weather, // or resource, // corresponds to a server defined in the client's mcpServers configuration, creating a logical namespace that abstracts physical server locations. The distinctive aspect is how the client uses URI parsing plus configuration to route requests without hard-coded server references in your application code. The pattern operates through a two-phase resolution process. First, parsing the URI scheme to select the target server from configuration, then forwarding the request to that server's specific endpoint. When you request weather, // weather /icons /sunny, the client consults its mcpServers config to find the server registered under the weather key, then routes the icon sunny path to that server's MCP interface. The Async Context Manager handles connection pooling and initialization handshakes for all configured servers up front, while the Unified Read Resource method provides consistent access to both static files and dynamic templates across servers. This approach solves the distributed resource coordination problem by externalizing server locations into configuration while maintaining a single programming interface. You gain the ability to recompose applications by changing URI configurations rather than code, making it ideal for microservice architectures where services may move or scale independently. The trade-off is requiring explicit server configuration upfront, but this enables proper connection management and eliminates the need for manual service discovery in your application logic. The same pattern extends to tools via call tool, creating a consistent model for all cross-server operations. Let's break it down line by line.
Async with client, #multi-server client.
Async Context Manager for FastMCP's multi-server client, configured via the mcpServers object where URI schemes map to server endpoints. The client automatically routes requests like weather, // and resource, // to their respective configured servers, handling connection pooling and initialization handshakes transparently. URI structure follows scheme // server /path, with schemes requiring explicit configuration before use.
#access resources from different servers. Weather icons equals await client, read resource. Weather, // weather /icons /sunny.
This uses FastMCP's URI-based multi-server routing. The client looks up the weather, // scheme in its mcpServers configuration to determine the target server, enabling transparent access to distributed resources through standardized URIs. The Context Manager automatically handles connection pooling and initialization handshakes for each configured server.
Templates equals await client, read resource. Resource, // assistant /template /list.
This fetches a reusable template from the configured resource server using URI-based routing. The resource, Scheme maps to a server defined in the client's mcpServers configuration, where each scheme, like weather, corresponds to a specific server endpoint. The context manager automatically handles connection pooling and initialization handshakes for all configured servers, enabling transparent multi-server access through standardized URIs.
Print F weather icon. Weather icon 0 blob.
This accesses binary weather icon data through FastMCP's multi-server URI routing. The weather scheme maps to a server configured in the client's mcpServers object, with the path weather icon sunny resolving to that server's resource endpoint. The blob attribute contains the raw image bytes, while the context manager automatically handles connection pooling across all configured servers.
Printf templates. Template 0 text.
This demonstrates FastMCP's multi-server resource access through configured URI schemes. The client uses the scheme prefix, weather, //resource, / to route requests to servers defined in the mcpServers configuration, with automatic connection pooling and initialization. The text and blob properties provide typed access to the retrieved resource content, whether static files or templated responses. Multi-server resource routing. FastMCP2's URI scheme system, weather, // resource, / creates a location-transparent namespace where each scheme maps to a pre-configured server in the client's mcpServers object, with the context manager automatically handling connection pooling and initialization for all servers. The URI structure follows scheme //server/path, where both the scheme and server name must match exactly what's defined in your client configuration. This pattern unifies access to both static and templated resources across distributed servers while maintaining server-specific capabilities.
The client that knows. Every server knows. No servers.